Okay, let me just exaggerate this. Let's say that this data was actually here. Now, what do? How do you fit a line passing through such a data set where at a specific value, let's say at x3 or x4, you have this and this, right? You have two data points. How do you choose? So what you do in this case is you use a best fit line. So you find a line, or a curve rather in this case, which this is the best fit line, which sort of explains the trend. It doesn't pass through all the data points. Okay, and the way you fit this line is by best fit line obtained by so you minimize the error between data and best fit curve. So it's a compromise. Okay. Now you could bias it towards one or the other. If you think that there is one data set which is more trustworthy than the other one, you could actually bias it. But more or less, when people do this, they find a best fit line which explains. So if you have, say that this curve is f of x, and you try to, and then this data x0, y0, x1, y1, so on till xn plus 1, so xn. Then what you do is you try to take the error, which will be summation yi minus f of xi, where f of xi is the curve. You take the square, you sum it over all the points, and you minimize this error. Okay, minimize, the minimization will give you the constants. So this, the end result of this will determine a cost. A cost is basically something you want to minimize. So in this case, the cost is given data point yi, given your fit, that is f of xi is going to explain the trend. Then because f of x is an approximate is an approximation to the trend, it's shown at the blue line there, it's going to have an error compared to the red asterisk, which means that there would be an error. And if you minimize that error, then you've basically found a function f of x, which basically sort of explains the trend. Okay, so that's the bigger picture. Let's get into the details of how we actually go about computing that f of x. Now, for any of these methods, you need to start assuming an f of x. So if you think that the process which you're trying to model is best explained by a straight line, then you go for a straight line. If you think it's a curve, you go for a curve. So curve, you would have to ask questions like, would it be a polynomial? Would it be something else? And so on. So what we'll do is we'll start off with linear regression, which is basically fitting a straight line. And then we'll go to other things like polynomials.